Okay, so hypothesis testing is one thing that everybody is doing, whether it is a PhD research paper or any research projects. So this is the most important concept of theory building. Whenever we want to develop a theory, we start it from the hypothesis, and if all the hypotheses are tested again and again and give you the same result, after some times it becomes a theory. So I hope you understand that without hypothesis testing, we can't develop the theory. So for theory development, hypothesis testing is the must to understand. So let me try to explain you the concept of hypothesis testing and how we test the different hypotheses. What are the different kind of hypotheses we have? Okay. So in the previous session, I will tell you the concept of statistical inference. Right. So statistical inference means when we do some study on the sample and the results are applicable on the population. So similarly, we are doing the hypothesis testing on the sample, and the result can be applicable on the population. So hypothesis testing is a way to draw the conclusion. So conclusion, uh, we designed some hypothesis. We start with some hypothesis and examine this hypothesis, and after that we draw the conclusion, and the conclusion must be applicable on the population. So we conduct all the process in such a way that whatever results are coming, they should be robust, they should not be biased, they can be generalized. So that is the issue in hypothesis testing. So hypothesis, what is hypothesis? So first of all, we understand what is hypothesis. So number one, hypothesis is an assumption which can be empirically tested. So my simplest definition of hypothesis is that anything which we can examine statistically, any assumption which can be tested with the help of a statistical test is called hypothesis. If any assumption which you cannot test with the help of statistics cannot be defined as hypothesis, right? So hypothesis is something which can be tested with the help of statistics. Hypothesis, I hope you understand that there are two type of hypothesis. One is called null hypothesis, and second is called alternate hypothesis. So what is null hypothesis? So you just see this quote which I take from the Google. So I am, so read this carefully. I am the uh, okay. So there is a problem in raising the hands actually. So I am what is the default, right? So the status quo, I am already accepted, can only be rejected. The burden of proof is on the alternate, I am the null hypothesis. So in this sentence, there are so many things which is mentioned. Number one, the null hypothesis is default, it cannot be accepted, right? So because as a researcher, when I started learning the research, in some of the books and in some of the papers, I mentioned that the null hypothesis can be accepted. Basically, null hypothesis cannot be accepted. The first thing which you should remember, that null hypothesis cannot be accepted. Basically, null hypothesis to reject hoti hai. So null hypothesis is not accepted. A null hypothesis can all be rejected, because if I say that males and females are equal in their salary, if I make this statement, if I ask that the average income of male, average salary of male is equal to average salary of female, so this cannot be accepted, right? Only this is already there. You can only reject this. So you have to understand the hypothesis in this manner, that we null hypothesis means a status quo which is already there. Null hypothesis is already there, and it is called neutral assumption. Null hypothesis is known as neutral assumption. It cannot be accepted, it can only be rejected, right? So there is a concept called innocent until proven guilty. For example, if we say that the performance of young people are equal to middle age group, is equal to old age group. So it is neutral, right? Now, as a researcher, by the observation or by conducting the data, by collecting the data, by observation, if we want to prove it, if we want to prove it wrong, then he can challenge this hypothesis, right? And the objective of this hypothesis is to reject it. Most of the researchers want to reject the null hypothesis because they want to challenge it. So the one thing is very clear, that null hypothesis is already there. The researcher objective is to challenge it, not to accept it, right? So if you are doing a research for accepting the null hypothesis, it has no meaning. The objective of the research should be to reject the null hypothesis. So, because I'm saying again and again, why? Because when you mention the hypothesis in the thesis or a research, be careful whether it is a null hypothesis or it is an alternate hypothesis. So, when it is a null hypothesis, your job is to reject it, and when you are mentioning the alternate hypothesis, your job is to accept the alternate hypothesis and reject the null hypothesis. So, this is one thing which should be very careful, because whenever I see this statement, the null hypothesis can be accepted. So I know this statement is a wrong statement. So if somebody writes that null hypothesis can be accepted, so this statement is a wrong statement. The right statement that null hypothesis is already there, you cannot accept it, right? You should write it cannot be rejected or can be rejected. So this is the first thing which I want to tell you all. Uh, so you just see these statements. We begin with the assumption that null hypothesis is true, and any difference between the sample statistic and the true population parameter is due to chance and not a systematic difference. So it is similar to the notion of innocent until proven guilty. Until proven guilty, that is, innocence is a null hypothesis, and we may or may not be rejected. So most of the researcher ask me that can we say null hypothesis is a negative statement? No. Negative, it is not a negative statement. It is a neutral statement. I always say that null hypothesis is never a negative statement. Null hypothesis is negative assumption. ये negative assumption नहीं होता. So basically null hypothesis is a neutral statement. It is a neutral statement, right? So whatever is there by default, it is neutral, right? So a null hypothesis cannot be positive, cannot be negative. It is always neutral, and the objective of the researcher is to reject it. So I hope after speaking again and again, this should be enter into your mind. So now let's me tell about the alternate hypothesis. So what is alternate hypothesis? Alternate hypothesis is the opposite of the null hypothesis. Alternate hypothesis kya hai? It is the opposite, against of null hypothesis. Now you can see in these two diagrams my null hypothesis, that if I there are two plants, and if I give biofertilizer to this plant, the growth is better, right? So this is my null hypothesis. Null hypothesis that do not increase plant growth. The application of fertilizer will not change any growth in the fertilizer. So there is no change in the application of fertilizer on the growth. Now I want to challenge this, right? And when I give fertilizer to one plant and not to any plant, so this is not provided, this is provided. So now I want to challenge the null hypothesis and want to prove that this fertilizer will definitely have an impact on the growth. So in null hypothesis, we assume that there is same effect on without and with, and here I want to challenge it and want to say I can challenge the null hypothesis and want to prove that fertilizer have a significant effect on growth. So this is what is null and what is alternate. You can understand null hypothesis is neutral and alternate hypothesis is opposite to it. So alternate hypothesis is the opposite of the null hypothesis. It challenges the status and it may or may not be proven. In is generally the hypothesis that the researcher is trying to prove. So when a researcher start with the null hypothesis, the objective should be to reject it rather than to accept it. So this is my point with taking care of null hypothesis and alternate hypothesis, right? So now read this statement, which makes you more clarity. We never accept the null hypothesis. We either reject it or not reject it. Okay, so one thing which normally people ask me, that when we should go with the null hypothesis and when we can go with alternate hypothesis, right? So this is the question I normally face from the researchers, that when null hypothesis can be considered and when alternate hypothesis can be considered. So my experience say that if you are going to apply the technique like structural equation modeling and PLS modeling, right? So all these exercise, all these techniques are basically designed for theory testing. It means when you have some theory, then only you can test it. So when some theory is already there and you want to test the theory in your context, in your respondent, in some technology, so then you can start with null alternate hypothesis, right? So when you are having a significant literature support, significant theory, then you can start with alternate hypothesis because you are testing that. Otherwise, if you don't have any significant literature support, if you don't have any uh, uh, theoretical support, you should not start with alternate hypothesis. You always started with null hypothesis. So I think now you have clarity then when to start with null hypothesis and when to start with alternate hypothesis. And when you start with null hypothesis, your objective is to reject it, and when you start with alternate hypothesis, your objective is to accept it, right? So you have to reject the null, accept the alternate. So this should be the purpose of the research. And you understand at this level that null means neutral, alternate means not neutral. Okay, so these are some of the points which you should know. Like in the process of hypothesis testing, the null hypothesis initially is assumed to be true. Data is collected, examined to determine whether the evidence is strong enough with respect to alternate hypothesis to reject the assumption. So the burden is placed on the researcher to show using sample information that null hypothesis is false, right? So if the sample information is sufficient enough in favor of alternate hypothesis, then null hypothesis is rejected. This is same as saying if the prosecutor has enough evidence of guilt, the innocence is rejected. And it is also possible that some error can be done in hypothesis testing. We define this error in terms of type 1 error and type 2 error, which I am going to explain. Okay. After that, now this is called sampling distribution, which is a, you can think is a contribution of the previous session, but actually this concept is more useful in hypothesis testing rather than in sampling distribution. So there are different type of errors you can see. Now, one thing I am asking to you, like if I say, uh, you can go to the market, ask any 100 people, take the data of the 100 people and ask them what is their average income. So suppose 100 people go to the market and collect the sample size, collect the samples and ask their average income, right? So I have 100 subsamples. So ये 100 लोग हैं जो market में गए और लोगों से उनकी income पूछी. So can I say the average income of all the people are same? All the samples are same? Can I say all the average of all the samples are same? The answer is no. The answer is no, right? So because two samples which may belong to the same population, but two sample mean cannot be same. Two sample mean may be same, may not be same. Most of the time they are not same. So if we calculate the standard deviation from this mean, if we calculate the, suppose this is the grand mean of all the, this is sample mean of first, this is sample mean of two, this is sample mean of three. So we are having the mean of the different samples, and if this is the grand mean. So if you calculate the standard deviation from this data, like every mean minus grand mean is square upon n minus 1. So this is called standard deviation of the sampling distribution. And this standard deviation is known as standard error. So I am defining here standard error. standard error is nothing. It is the standard deviation of the sampling mean. But the problem is that we never have this facility to draw different samples from the population and calculate the standard deviation. So we have a approximation formula. This formula say that the sample standard deviation of one sample divided by n minus 1, this is called sampling error. So if this is the standard deviation of a sample, then we are using this formula. And if we know the population standard deviation, then we use this formula. So this formula is known as approximation formula to calculate standard error. And you may not believe that how much this standard error is important for hypothesis testing. Almost in every hypothesis testing, we are using the concept of standard error, right? So now I'm asking you some of the terms which uh, you may understand. One is called sampling error, right? So one of the concept is called sampling error. One is called non-sampling error, and non-response error. So I will explain you these two things. Non-response error, right? So there are different concepts: sampling error, non-sampling error, non-response error. So first is sampling error. Sampling error means because you are picking different samples, so some error may come by chance. Sometimes because of the sampling method, there is some error in the sample. This error, which is by chance error, this is called chance error. Sampling error is also known as chance error. So because whenever you pick any sample, it may be possible that its mean is different from the population, right? So this error is called sampling error. Like for example, if I say you that suppose in a college the average CAT score of the student is 98, right? So if you pick 100 students and the average CAT score is found to be 97, so in that case this difference of 1 is due to the chance, due to the sampling process. So we call this sampling error. So this standard error is nothing, it is a measure of the sampling error. This standard error is nothing, it is a measure of sampling error. So I hope you understand this. And I am giving you another example. Suppose uh, it is found that the average age of the cancer patients is 46. Like suppose this is given to you that the average age of the cancer patients in India is 46. Now you want to test it. So you take the sample of 100 people, 100 cancer patients, and calculate the average age. Suppose the average age is found to be 45 or 46, right? Or 47. So the difference between the population mean and the sample mean is because of the sampling method, sampling error. So this error is called standard error. I hope it is clear. And there are some errors which are due to other reasons. Like for example, if you change your research method, and because of the research method, the results may be different, right? For example, if you select the 100 patient and you are giving a medicine to them, and or if you are taking the patient from only Max Hospital, or if you are taking the patient from Fortis Hospital, it may be possible the sample mean is different from the population mean. So this is called non-sampling error, because this error is not coming from the random sampling. This is coming from the method which you are adopting in the study, right? So suppose you're sampling, you're adopting these convenience sampling, right? In this case the error may come from the convenience sampling method, right? If you decided to conduct this study in Delhi only, so it then some of the error may come because of this decision. So the error which is coming from your sampling method, your difference in the sampling method, so those errors are known as non-sampling error. And sometimes you are having the non-response error, because in one presentation, one panel member asked that what do you have non-sampling error in the study? So suppose if I ask you, you are conducting one research, and I'm asking you, uh, do you have non-response error in your study, right? So I know that at least 80% of you will not understand what is this non-response error, right? Because these terms are not very common in the research. In most of the books, these are not mentioned. But when I conducted a small research and find out the concept of non-response error, I found that when you collect the data from the public, right, there are many people who don't want to give you the data, right? If you go to the bank and ask the bank managers, sir, I want to collect the data from the people, suppose some employee say no to participate, right? So suppose if these respondent who say no to participate, suppose these people gives you the data, is will the result will change? Will the result will change? If yes, then it is called non-response error, right? I know that uh, when suppose I'm taking class in a university, I know that there is a group who don't like me, right? So I make all of my efforts to take not to not take the feedback from them, right? Because I want to exclude them. Why? So that my feedback will comes up. But the problem is that if these people who avoid or whom I exclude to take the feedback, if I included them, will the result will change? You say yes, definitely. So now I hope you understand what is the non-response error. Non-response error means the people who say no to give you the data. If by chance you collected the responses from these people, will you get the different results? So this is called non-response error. So in research, sometimes this non-response error is also important. So in the cases, you can say that we divided the error into two parts. This is called sampling error, and this is called non-sampling error. This sampling error is called chance error because by chance you never get the result because of the population, because you are picking a sample, so some error is possible. That error is called sampling error. And there are non-sampling error because of your questionnaire is wrong, your sampling method is wrong, your behavioral effect, matlab you are biased, you are already biased, or your respondents are biased. So then you will get non-sampling error. So as a researcher, you should take care of these errors, and this is by default. So sampling error is by default. You cannot manage the sampling error, but as a researcher, you should take care of non-sampling error. Actually, this sampling error can be adjusted with the hypothesis testing, but actually non-sampling error cannot be adjusted in hypothesis testing. So that is a problem in hypothesis testing, and we have to take care of non-sampling error as a researcher, because most of the researchers say me, sir, I'm not getting the reliability in my data, I'm not getting the validity in my data, I'm not getting the normality in my data. So all the problem are coming because of the non-sampling errors, I'm telling you. So if you are very, very cautious and careful in collecting the data, so you can remove most of these non-sampling error, and the error which is only there in the data is sampling error. So I hope you understand all the error terms, all the errors which are there, which are related to the sampling, and all the errors are affecting your hypothesis testing also. So now I am going to tell you how the errors are adjusted. Okay, so in this slide, I defined basically the standard error, and from the concept of this standard error, we designed one important method of hypothesis testing, and this method is known as confidence interval method, right? So the this slide I already explained in the previous one, where I say that this standard error is nothing. It is the standard deviation of the sampling distribution of the statistical mean. So we decide this formula to calculate the standard error. A standard error is nothing. It is the standard deviation of the sample divided by a square root of the n. But there is a little confusion in n minus 1. When you use the standard deviation of the sample, normally we use n minus 1, and when we take the standard deviation of the population, then this is n. In sample, it is n minus 1, and it is for population it is n. But actually, I see in many books this concept is ignored entirely. So most of the books and the even softwares are using the concept of n. So they say that standard deviation divided by n is the formula for standard error. Otherwise, the right concept is that if you are using the standard deviation of the population, you should divide it by square root of n. And if you are taking the standard deviation of the sample, the n should be n minus 1. Yeah. Otherwise, I know that in India they are not considering this concept and take always n. Well, no problem. We also continue with the n. Okay. Now I am telling you there are two methods of hypothesis testing. The first method is called confidence interval method, and second method is called p-value method. So to explain these methods, I have to explain the concept uh, confidence interval method and p-value method. These two methods I can explain only by explaining on a whiteboard. This is the whiteboard, and I am going to use this whiteboard. Okay. So while explaining all the concept, I assume that you must know the normal distribution, the concept of normal distribution. Suppose this is a bell-shaped curve, and it is a probability distribution where the this x-axis is indicating the z-score, the average z is 0, and it goes up to approximately +3 and -3. So this is normally the range of z in a normal distribution. Yeah, but actually this tail never touches the axis because there may be some outliers here. Now this distribution is divided into two parts. One part is this, and this part is known as acceptance region, and this part is known as rejection region. So we define the normal distribution into two categories: acceptance region and the rejection region. Suppose it is given that let me give you one example. Somebody told me that in IT sector companies, the average age of the employees is 35 years. So it is a population mean. I call it mu. Suppose it is given that the average age of the employees in IT sector is 35 years. Now I want to check it whether it is true or wrong. So this 35 years and one figure, I also require what is the standard deviation of the data. So suppose standard deviation is 2 years. So I have two figures with me, the mu and the standard deviation. The mu is 35 years and sigma is 2 years, right? So I have two things. Number one, I have a Chebyshev theorem. This theorem is say that your 95% of the population lies in the range of mean plus minus 2 standard deviation, right? So let me explain you this concept first, then I will explain the acceptance and rejection region. So with the confidence level of 95%, I have this mean plus minus 2 standard deviation. So my mean is 35 years, and my this is 2 multiplied by standard deviation 2. So if I take plus and minus, if I take plus, if I take minus, it will be 31. If I take plus, between 39. So it means 95% of the population should lie between 31 and 39. Now I pick a sample and found that the average age is 26. So because my value is not coming in between this, so I will reject my hypothesis, right? So this is the concept of confidence interval. uh, you calculate the higher value upper limit and lower limit. This is the lower limit, this is the upper limit, and with the help of this upper limit and lower limit, we can find out whether my sample belong to this population or not. So this is the concept we used in case of Chebyshev theorem, but in hypothesis testing we make a small change. So now I'm using the same concept in case of hypothesis testing. Now in hypothesis testing, the concept of acceptance and rejection region is same, but now my upper limit and lower limit depends upon standard error. So I write here mean plus minus 1.96 multiplied by the standard error. Uh, okay, I am taking only the plus, and in second case I am taking only the minus. So mean minus 1.96 multiplied by the standard error. So I calculate the upper limit, I calculate the lower limit. This is my upper limit, this is my lower limit, and this range is known as confidence interval. Right, this is the interval, confidence interval. Suppose this confidence interval is like 2 to 4. Now I calculate the actual mean, and if it is like, if it sample mean, and if it lies in this range or in this range, so I reject my null hypothesis. And if the sample mean lies in the confidence level, then I accept my null hypothesis. So the confidence interval method say that this is confidence interval method, which is exactly equal to mean plus minus 1.96. And I am assuming the confidence level of 95% multiplied by the standard deviation divided by n, or this formula is the formula which gives me the upper limit and the lower limit. Right. So if my sample value lies between these two limits, I accept the null hypothesis. And if the sample belongs to this rejection region, then I reject my null hypothesis. But one thing which I want to tell you that this method was a older method, and now in 90% of the softwares, this method was captured by or take over by p-value method. So now I am telling you the p-value method, which is most important method. And uh, nowadays more than 90% of the softwares, they are using the p-value method. They are not using the confidence interval method. Hardly in hardly 5% cases, or for 2% cases, you can see this confidence interval method. But this method was very old method. Now most of the softwares are using p-value method, and the concept is very clear that using the significant level alpha is type 1 error. Here alpha is the type 1 error, which I am going to explain you. And if p value is less than alpha, we normally reject the null hypothesis. And if p value is more than alpha, we failed to reject the null hypothesis. In most of the cases, we assume that alpha is 5%, so it is replaced by 0.05. And I am telling you one very interesting case uh, regarding this p-value. I taught in one class that whenever p-value is less than 0.05, you reject the null hypothesis. Whenever the p-value is more than 0.05, we accept the null hypothesis. Then the HOD of my college called me and told me that you are teaching the wrong things to the students, and you are telling that if p value is less than 0.05, null hypothesis should be rejected. I said yes, it is rejected. But he said that no, you are wrong, Mr. Chauhan, you are wrong. Recently I submitted my thesis in FMS department of Delhi University, and in my thesis I written everywhere that whenever p-value is less than 0.05, null hypothesis can be accepted. Right. So then I said, sirs, you are wrong, I am not wrong, please kindly check your knowledge. So then the HOD read this concept from many books and found that he submitted the wrong thesis in the university. So but the problem is that in university nobody read his thesis, and he take the degree. So this is a problem in India, that nobody read your thesis, and whatever you write, it will be cleared. Okay, so well, this is the case. I hope you understand p-value method. Now I am going to explain the mathematics of p-value method, because without understanding that, you will not get clarity. uh, so again, I'm going to the whiteboard, and this is the normal distribution, and this is my 95% confidence level. This is the 95% confidence level, this is the value of z, and this is 0, and the z value is -3 here. But I am telling you, this z value is, you can understand, it is 47.5, and it is -47.5 in percentage. I'm telling you in probability percentage. This is the probability. So 47.5 plus 47.5 becomes the 95, right? And this portion is covering only 2.5% probability, and this portion is also 2.5% probability. So this is 2.5% and 2.5%, because our confidence level is 9.5%. And we know with clarity that if my sample lies here, the null hypothesis will be rejected, otherwise not. So how to decide? Now software calculate one thing. Software take this boundary, and the distance, probability distance, this is exactly 50%, and the probability distance, this distance is also 50%. So software calculates, suppose your sample lies here, so software will calculate this distance, and this distance is calculated by this distance is calculated by 0.5 minus p value. This is the p value. This is the probability value of z. Probability value of z. So, and because we are covering only one side, then we multiply it by 2. So this is the formula for p value, and okay, now it is p. So I can write p is equal to d multiplied by 2, where d is the distance from the extreme to the sample, and this p value can be calculated by d. What is d? 0.5 into probability of z multiplied by 2. So if the probability value is less than 0.05, null hypothesis can be rejected, and if p value is more than 0.05, null hypothesis cannot be rejected. So this is the concept of probability value. If you don't like mathematics, you can uh, avoid this, and the simple calculation of p value is that p value is equal to d multiplied by 2, where d is the distance from the extreme to the sample, where your sample lies. So this is called d. And why I'm multiplying with 2? Because I'm calculating for both sides, so this side as well as this side. So I'm taking my alpha is 5%, and if my p value is less than 0.05, then you should remember only this thing: 0.05 rejected, and p value more than 0.05, null hypothesis cannot be rejected. So this is the conclusion you should understand of hypothesis testing. So I hope it is clear, and let me move to the PPT. Okay, so we are discussing we are here. So p value method we will use in more than 95% cases, and confidence interval is available hardly 2 to 5% cases, because yesterday I was taking a class in process, and where the confidence interval method we are using. But otherwise, in most of the cases, you have to test the hypothesis with the help of p value. Okay, so I already explained the p value approach, so don't worry, this is already explained. And now I am going to explain the concept of type 1 error and type 2 error. So type 2 error and type 1 error I can explain with the help of this example. Okay, let me take you to the whiteboard again, where I can explain the type 1 error and type 2 error. Okay, suppose this is a very old example, and you can see this example in most of the books and video lectures. But because I am teaching you type 1 and type 2 error, I am also following the same example. Okay, suppose you are the judge of a court, and there is some culprit in front of you, and this is fact that he is an innocent person, and there are two possibilities, whether he is an innocent person or whether he is a guilty person. So this is a fact, and now this is your decision. So you can decide whether he is innocent or whether he is guilty. So this is the fact and this is the decision. So if the person is actually innocent and you declared him innocent, no problem, right decision. If the person is guilty and you also declare him guilty, no problem. So these two are right decisions. So this is a correct decision. This is a correct decision. It is also a correct decision. Now the problem is that if you declare an innocent person guilty, this is a wrong decision. And if you declare a guilty person as innocent, this is also a wrong decision. Now the problem that is that we are having the two wrong decisions. Wrong decision of declaring innocent person as a guilty person, and declaring innocent as a guilty person a innocent person, right? So we define these two wrong decisions as alpha and beta. So this alpha is known as type 1 error, and the beta is defined as a type 2 error. So this is called type 2 error. Now the problem is that we have to decide uh, which error is big error. This error is dangerous error, or this error is more dangerous error. But actually, I personally believe that this error is more dangerous as compared to this decision. But the law say that in law there is a popular saying that 100 innocent people, 100 guilty people you can free, but you cannot declare a single person as a guilty person. मतलब 100 मुजरिम अगर छूट भी गए तो कोई दिक्कत नहीं है, लेकिन एक भी innocent person को guilty नहीं होना चाहिए. तो actually because of this law we always focus on the alpha. And what is the official definition of alpha? Alpha is the probability. Alpha is the probability of rejecting. Probability of rejecting a true null hypothesis. A true null hypothesis, right? So this is the definition of type 1 error, when the null hypothesis is actually true and you are saying that we are rejecting it. For example, I'm giving you a very simple example. Suppose God make woman and male and female as equal, right? But if you want to prove it that the female are better than male, or male are better than female, then you are committing the type 1 error basically, because by default they are same and you are proving it wrong. So this problem is known as type 1 error, or it is called alpha. So I hope you understand alpha. Alpha can be defined as the probability of rejecting a true null hypothesis, or a probability of rejecting a hypothesis when it is actually true. So this alpha is considered to be more dangerous in statistics, and we decide the level of alpha. And in medical science, the alpha should be considered as 0%, but in social science, it is considered as 5%. So therefore in social science the alpha is 5%, and confidence level is equal to 1 minus alpha, which is 100 minus 5%, and my confidence level is 95%. So if my alpha is 5%, the hypothesis testing, if I do hypothesis testing with alpha of 5%, it means I am making the conclusion with 95% confidence level. So this is the concept of alpha and the confidence level. And related to the beta, we ignore completely this beta. We completely ignore this beta. We don't take care with this beta. Why? Because if we decrease alpha, beta will increase. If we increase alpha, beta will decrease. So both are moving in the opposite direction. You can't manage alpha and beta at the same time. So it is decided in statistics that we should take care only on the alpha. We should not take care on the beta, right? Because beta is not important, alpha is important. So in statistics, I have not seen controlling the beta I have only seen the controlling of the alpha. So in your thesis also, you have to decide what is the level of alpha. It is most of the cases it is 5%, and if your alpha is 5%, the hypothesis testing is done with 95% confidence level. So this is the condition of statistics. And let us go back to the hypothesis. So now you read the definitions of type 1 error and type 2 error. So here you can see that the type 1 error, which is known as alpha, it is the rejecting a true null hypothesis when it should not be rejected. Similarly, considering a serious, it is a serious type of error, and the probability of type 1 error is called alpha, and the alpha in statistic is also known as level of significance, right? So uh, whenever you write a thesis, you have to report what is the level of significance of your study. So level of significance, mostly it is 5%. Now type 2 error, how to define the type 2 error? For knowledge, you should know how to define a type 2 error, because in practical you never control this type 2 error, but definition wise you should be clear. So it is failed to reject. So when you are accepting a false null hypothesis, say in simple language we can say that when we are accepting a false true hypothesis, sorry, a false null hypothesis. When we are rejecting a false null hypothesis, then this probability is known as type 2 error, and this is called beta. So if you remember, in p-value method, we take care of this alpha. Uh, Here you can see that we are denoting this alpha. So if probability value is less than alpha, then the null hypothesis should be rejected, and when this p-value is greater than alpha, the null hypothesis should not be rejected. So the concept of p-value is related to the level of significance, which is actually the value of alpha. Okay, so here I just want to know that whether you are with me or not. I am. Uh, Please kindly write in the chat box that are you with me or you are not with me. Hmm. Okay, so I'm happy that most of you are writing yes. Oh, great! Because these concepts are very difficult concept to understand, and it is a success that I'm able to explain you. Great. So let me go back to the slide. Confidence level and p-value method. So there are two methods: confidence interval method and p-value method. One example I'm giving to you. Suppose I am running a regression model, and my regression model is equal to y equal to alpha plus beta into x. In this case, my beta is the parameter, and my null hypothesis is that this beta equal to 0, right? So you can say that this is my null hypothesis, and I have two options of testing this hypothesis. One hypothesis say that you can find out the confidence interval. Confidence interval means my lower limit is equal to beta minus 1.96 into standard error, and upper limit is equal to beta plus 1.96 into standard error. Suppose my lower limit and upper limit is minus 0.6 to plus 0.5. So now I'm asking you, what should be there, right? Should I accept the null hypothesis or should I reject the null hypothesis, right? So if you see this interval, the interval is lying, this interval is saying you that 0 is coming in between. You can see that beta is equal to 0, which is coming between this range. So my conclusion is that null hypothesis is accepted. No, sorry, cannot be rejected. So I will write cannot be rejected. Similarly, if this interval is like 0.2 and to 0.5, so you know that your sample is not lying in between this. So now you can write null hypothesis rejected. So this is the method of using the confidence interval method. Similarly, in probability p-value method, it is very easy. Before moving to the forward, I want to show you some practical examples from SPSS. Let's take SPSS file and I will show you these two methods. And I am opening the SPSS file just to show you the difference between the two methods, because in some cases software will give you both the methods, confidence interval method as well as the p-value method. So I'm okay. So this is the SPSS file. I hope you can see that. And let me check whether you can see it, whether you are watching it or not. Yes, it is shared. And I am opening a database. So I am opening a database from t-test, because in t-test we can see this Z confidence level and p-value both. So my workshops and SPSS for beginner, I can go day 2. So okay. So let me open this file. It is a case of paired sample t-test. I am showing you just paired sample t-test, where I am telling you this, and click OK. Now, what I want to show you here, just kindly see in this test, I have this method is called p-value method, and this portion is called confidence interval method. So my hypothesis is that the mean of one sample is equal to mean of second sample. This is my hypothesis, and I can test with the help of confidence interval method. This is called confidence interval method with 95% confidence, and this method is called p-value method. So just for demonstration, I am showing you this concept. So now let's see the mean value, right? So the mean of first group is 43, and the mean of second group is 60, right? So what is the difference of the mean? So 60 minus 43.5, the difference is of the mean is found to be 16.5, right? So basically my null hypothesis converted to that whether this x2 minus x1 is equal to 0 or not, right? So the null hypothesis that this is 0, right? So I have to check the both the values. Let me run it again so that I can take the output somewhere upper, right? Yeah, now you can see clearly this mean I want to check, and the null hypothesis that the difference in the mean should be 0. Now tell me whether this minus 16 is the part of, okay, first of all, this p-value is very easy. Now you can see that the probability value, this significance two-tailed value is probability value, and this probability value is less than, this probability value is found to be less than 0.05, 0.05, right? And so we can say that the null hypothesis can be rejected. So we are having very clear conclusion after this, right? And in most of the cases we identify on the basis of p-value, but how to interpret this lower and upper value, I want to show you that minus 20 is my lower limit, minus 12 is my upper limit. So can 0 lie in between that? क्या 0 minus 20 और 12 के बीच में आएगा? I am asking you very simple question. whether this upper level and lower level have the zero? You say no, no. Zero will not lie between 20 and 12. So if zero lie between that, it means null hypothesis cannot be rejected. But we know that zero is not exist between 12 and 20, so null hypothesis rejected, right? So most of the softwares will give you the results on the basis of confidence interval as well as on p value. And most of the people tell you the p value, but nobody will tell you the lower and upper value, right? Because 99% of the researchers are using the p value, they are not using the confidence interval. But the problem comes when some of the softwares will not give you the p value, they will give only the confidence value. So then you will have a confusion that how to decide, right? So for that purpose, I am showing you this concept. Okay, now let me go to some other example. uh, let me come finish this, open some other file, uh, open the data, and now I am using this data set. Okay, suppose I am having this gender as one of the category variable, and I want to check whether their level of familiarity with the internet are equal or not, or let's say internet usage. So I want to see whether the internet usage of male and female are equal or not. So this is my hypothesis, whether the male and female are using the internet equally or not. So I want to check the hypothesis, and I'm going to apply independent sample t-test, and internet usage is my test variable, and gender is my grouping variable, and one I give for male, two I give for female, continue, and okay. So now I just want to show you one thing which is more important, that the software gives me two facilities: testing the hypothesis by the confidence interval. Now software is giving me two facilities: testing with the help of confidence interval and testing with the help of p-value. So this method is known as p-value method, and this value is known as confidence interval method. So I personally like p-value method, but in some time I have to check all this also. Okay, so now we will go to the first part. Okay, so tell me, will zero lie between this and this? क्या जीरो 6 और 10 के बीच में आएगा? आपका आंसर है नहीं, नहीं आएगा. सो क्या जीरो 6 और 10 के बीच में आएगा? नहीं आएगा. सो नल हाइपोथेसिस रिजेक्टेड, right? Now in this case, in case of p value, uh, this null hypothesis is also rejected, right? Because the p value is less than 0.05, right? So now I think you have clarity that how to test with the help of p value and how to test with the help of uh, confidence interval. Yeah. So okay, now I am I'm asking you question with the help of some more example. Okay, so let's one more last example. So suppose I want to check the I'm taking the example from regression model. Okay, y is equal to alpha plus beta into x, and my null hypothesis is that beta is equal to 0, and p value method. And first of all, I am showing you confidence interval. Confidence interval say that lower limit is equal to 0.4, upper limit is equal to 0.7. So now tell me the conclusion. Null hypothesis accepted or rejected? Okay, tell me the, now use your knowledge and tell, can I reject the hypothesis or accept the hypothesis? Okay, so I am getting only the answer that rejected, right? So it means because 0 will not lie between 0.4 and 0.7, so null hypothesis rejected. Okay, And if p-value is 0.001, it means null hypothesis rejected. So after this concept, I am sure that you will understand how to interpret from confidence interval and how to interpret from p-value method. अगर अभी भी आपको समझ में नहीं आया तो आपको मेरे ख्याल से फिर कभी समझ में आएगा ही नहीं. So let me go to the next part now. Okay. So we are discussing the PPT, and I demonstrate you how to interpret the p-value method and confidence level method. Okay, now let's do. This is clear. P-value approach I explained. Okay. Now I am telling you the different type of null hypothesis we use in the different test. The here I am showing you the 5 tests in this slide, and all the 5 tests are popular tests of hypothesis testing. So if you are doing some course of hypothesis testing, these are the following 5 tests you have to understand. So we are discussing the t test, where uh, the the null hypothesis is that there exists no significant difference. So here the word is difference is very important. So whenever you are testing the difference between the two groups, so you have to frame the hypothesis like there exists no significant difference. And here alternative hypothesis that there exists significant difference, right? Similarly, when you apply a chi-square test, so the null hypothesis is that there exists no significant association. Here the word association is very important, so I am circle it. So I am circling some important words. Okay. So now read these words very carefully. So when I want to check the difference between two groups, my null hypothesis that both are same, there exists no significant difference. So I will apply the t-test. So you will apply t-test. When I want to check whether I want to check the association between two categorical variables 1 and categorical variables 2. So when I check the association between the two categorical variables, I will go for chi-square test, right? So you have to see how I am framing the null hypothesis. So I am giving you examples of all the tests once again, and after that I am sure that the concept of hypothesis testing will be clear. Okay, so let me go to the whiteboard again, and I want to explain when the hypotheses are applied. The first hypothesis we apply for difference, and I'm telling you that 90% of the hypotheses belong to these 5 hypotheses. So you have to understand all the 5 hypotheses, and after that the hypothesis testing will be entirely clear. Suppose I want to check whether the mean of the population is equal to the mean of the sample. So my null hypothesis is that the sample mean, which I expresses by this, and is equal to mu. Mu is population mean. Sometimes I will check the whether the mean of two different samples. This is x1 bar, this is x2 bar. Here my null hypothesis is equal to not equal to a semicolon, that x1 bar is equal to x2 bar, right? Uh, Sometimes I will calculate the pre and post. So this is called event. You calculated the data before advertisement and after advertisement, before training, after training. So this is called pre-sample, and this is called post-sample. This is called repeated sample. And then my null hypothesis that the mean of post equal to the mean of pre. So in all these cases, we are applying the hypothesis of difference. Why? You can also write here that x bar minus mu is equal to 0, or x bar minus x2 bar equal to 0. Let x post minus x pre equal to 0. So this is called the hypothesis of difference, right? So here, one thing I'm just clearly speaking, that suppose the way you write the null hypothesis is, there exist, this is a standard language of writing the hypothesis. There exists no significant difference between, for example, males and females with respect to their average performance. So in this way, we write the null hypothesis of the difference, right? So whenever you want to write the null hypothesis, the right way of writing the null hypothesis is this. And which test we are going to apply? T test. Now I am telling you the association. Suppose you want to check whether the categorical variable, this is category 1 and this is category 2, and you want to check whether the categories uh, are related or not. For example, this is male and versus female, and this is less talkative and more talkative, right? So I want to know whether male and female are can be defined as a less talkative and more talkative, also not. In my life, I work with different institutions, and I know that whenever the director called faculty for meeting, 90% of the faculty meeting will be dominated by ladies faculty, and we always prefer to sit in the back, sit the last chairs, right? All the male faculties sit in the last chairs, and all the female faculties sit in the front chairs, and director and ladies talks too much, right? So I can here my null hypothesis is that, and there exists no significant, so I want to challenge this hypothesis. There is no significant association between gender and level of talkative, level of talk, some, right? So I know that this hypothesis can be challenged by anybody. So so if you want to challenge this hypothesis, which test you will apply? So this association one is very important, and you have to apply chi-square chi-square test. So chi-square test is used to check the hypothesis of association and between the category number 1 and the category number 2. You cannot apply the chi-square on the interval scale data. You can apply chi-square only on the category data. Okay, so this is the second case of hypothesis. Now third case I am telling you, this is the case number third. This is the case of relationship. Relationship means, suppose I want to see the relationship between, let's say, sales and advertisement. I want to see the relationship between interest rate and money supply. Or I want to see the relationship between GDP and money supply. So I just want to see the relationship, right? So the null hypothesis will be, there exists no significant relationship between variable x1 and variable x2. And which test we are going to apply here? Pearson correlation test. Pearson correlation test. So whenever you want to design hypothesis to find out the relationship, this is the right way of explaining or mentioning the hypothesis. And frankly speaking, I found that most of the research scholars don't know how to make the statement of hypothesis. So here I am telling you how to make the statement of hypothesis in case of relationship. Now in fourth case, this is the case of, let's say, I want to see the impact of interest rate on GDP. So in previous example, this direction was not there. Now I want to find out the direction. I want to see the impact of advertisement on the level of sales. So now my hypothesis will be, null hypothesis will be, there exists no significant impact of advertisement on sales, right? But if you want to write the alternate hypothesis, you can say that the advertisement have a significant impact on sales. You can write a very simple language. But when you write the null hypothesis, better if you write in this language. And to check this hypothesis, we apply regression model. We apply the regression model to check this null hypothesis, right? So this is the null hypothesis for the regression, and after that, the hypothesis which I'm taking is of ANOVA. ANOVA. So in ANOVA, we are having 3 or more than 3 groups, and we want to check whether the average of all the groups are same. For example, I am taking Mumbai and Delhi and Bangalore, and I want to check whether the average recovery rate from corona in both the cities are equal or not. So my null hypothesis will be the this is the null hypothesis, the average recovery of patients from corona is same, right? So I can write the null hypothesis like this, right? So I explained you how hypothesis can be designed in all the 5 cases, right? So you can see all the hypotheses, and I think this is my last slide. So hypothesis testing, I explained whatever I know about the hypothesis testing. I explained you like that. Okay, so this is confidence interval explained, p-value explained, and hypothesis type 1, type 2 error is explained, p-value, confidence interval, p-value is explained, standard error is explained. Okay, so now I am opening the session for query. We are having 15 minutes, and if you are having any query from the session 1 and session 2, I like to answer that.